Hey students, we've had some questions about number 6 from our Math Excel scatter plots assignment. So just making a quick video here to hopefully help you on this one. So it says, we've got this table, number of bacteria over a certain number of hours. So we have the first 8 hours and the number of bacteria. So the first thing we need to find is the correct graph. So I've went ahead and put this data into Desmos here because this is our graphing calculator that we use. Remember, I can click this plus to be able to add a table. So that's what I did. So here's my table. This data obviously isn't showing up on the window that I have here. If we come back here, we can see that it shows all graphs are shown in, this is my window. So 0 to 10, 1s. And remember, I can change that here. So that is my x-axis, okay? My x-axis goes from 0 to 10, and its step is 1. Okay, so modified that one. And then for my y's, 0 to 1200 by 200s. So let's change that one here to 0 to 1200 and step 200s. Okay, so if I come off, all right, so there's all my points, and I can see those there. And we can see that it most closely resembles letter D here for me. All right, so check that one. All right. Now the next part, which is a suitable model for the data, a linear or an exponential model? Well, there we have to kind of remember those two general shapes. This is not a straight line, so we have an exponential model because the data shown is a downward non-linear trend. It's not a straight line, it is an exponential downward trend, okay? All right, here's kind of the tricky part that most people have been having questions about, is actually coming up with this equation. So Desmos will do this for us again, but we need to enter in what is called the regression model. So the exponential here, so we know it's going to be this top one because it's exponential. Remember, that's y equals a times b to the x. So that's these two letters here, a and b. So to do this in Desmos, we do y1, because that was our variable up in our table. And we don't do equal, we do this little squiggly looking thing, which is just to the left of the number 1 key. A times b. Okay, then I need to get into my exponent here. Let's see, hold on, I gotta move this screencastify thing here. Hopefully I can. Hide tools, there we go. Okay, so now I can get in that exponent, and there is where my x goes. So I just hit y1, I just hit the number 1, and it automatically made it that subscript. Same with the x. I hit 1 after the x, and it automatically made it that subscript as well, okay? All right, the last thing is we need to check this log mode right here. And this gives us the information for our equation. You can see this line, okay, is the closest line that fits all these data points. Here's my A, and here's my B. Those I can substitute now in here to Math Excel. So A, 1502.97 says to 2 decimal places, so that's everything I've got. 1502.97. And then B, all right, to 2 decimals, looks like 0.72, rounded to 2 decimals there. So come here, 0.72. All right, so that's how I get my equation. And then the last thing it asks, using this model, predict how many bacteria there will be after 11 hours. Well, 11 is my x, so I take this equation and substitute 11 in for x. So let's come back here to Desmos, 1502.97 times 0.72 raised to the x power now, and that was going to be 11 for us. So approximately 40.51 if it wants to that many decimals. Oop, nope, round to the nearest integer. So for us here, that is just going to, let's see, we'll have to round up. So 41 bacteria is our approximation after 11 hours. Okay, hopefully that helps.